We want to show that x cubed minus 2x squared plus 0.5 equals 0 can be rearranged to give x equals the cube root of 2x squared minus 0.5. So we're taking an equation in the form f of x equals 0 and rearranging it into the form x equals g of x. So let's start with x cubed minus 2x squared plus 0.5 equals 0. The fact that this has a cube root suggests that we're trying to get the x cubed on its own. So add 2x squared and take away 0.5 from each side, and we get x cubed equals 2x squared take away 0.5. We can then simply take the cube root of both sides to produce the result required. We now want to show that x cubed minus 2x squared plus 0.5 equals 0 has a root between 1 and 2. So let's let f of x be equal to x cubed minus 2x squared plus 0.5. f of 1 is then going to be 1 take away 2 plus 0.5, which is minus 0.5. f of 2 is equal to 2 cubed, take away 2 times 2 squared, plus 0.5, and this comes to 8, take away 8 plus 0.5, which is 0.5. So we have a change in sign, and we know that a change in sign implies a root. So we must have a root between 1 and 2. We now want to use the iteration formula xn plus 1 is equal to the cube root of 2xn squared, take away 0.5, to find the root between 1 and 2, correct to 1 decimal place. We're going to take x0, our first x, as 1. Let's look in more detail at the formula. xn plus 1 is the x that comes after xn. We know that n plus 1 is the next integer after the integer n. It follows that xn plus 1 is the next value of x after xn. What this means in practice is that we find a start value such as x0, and then x1 is produced by substituting x0 into the formula. We then find x2 by substituting this value for x1 into the formula, and so on. In this way, we can produce x3, x4, and so on. Since we're doing the same calculation repeatedly with a new value of x, this is called an iterative process. So for this one, we're told to take x0 is 1. To produce x1 then, we substitute this value for x0 into the formula. So we have 2 times x0 squared, take away 0.5. x0 is of course 1, so we have the cube root of 2 times 1 squared, take away 0.5, and this gives us the cube root of 1.5. This calculates to give 1.1447 and so on and we need to store the whole of this value on the calculator, as this is our value of x1. This will be used in the subsequent calculation. To find x2, we know that we're going to do the cube root of 2 times x1 squared, take away 0.5. So we have the cube root of 2 times this value squared, take away the 0.5. Which gives us 1.2847, and so on. Clearly this could take a very long time. However, there is a calculator shortcut that we can use. If you look at your calculator, it should have an ANS button. This button uses the answer to your last calculation in any subsequent calculation wherever you put it. Using this, we can shortcut this process quite considerably. Since x0 is equal to 1, we put into the calculator 1 and then press equals. This stores 1 as the last answer. We can then set up the calculator with the formula in terms of ANS. Most calculators have a cube root button, but if you don't have this cube root button, you should put brackets around the bit that's going inside this cube root and raise it to the power 1/3. If you do have the cube root button, press the cube root button and inside the cube root put 2 times answer squared, this is our 2x squared, take away 0.5. What then happens when you press equals is that it does the calculation using ANS equal to 1, therefore giving us the value of x1. The next time we press equals, it uses the answer to x1, the 1.1447 and so on, in the position of answer in the formula, so it produces x2. So all we then need to do is keep on hitting the equals button to get the next x. So we have x0 is 1. We found that x1 was 1.1447 and so on. x2 we found to be 1.2847 and so on. And then pressing the button on the calculator again will give us the value of x3. This is 1.409 and so on. You should be checking that using our method with the answer button, you can reproduce these answers. If we continue pressing the button until we get to x30 or so, we find the answer is 1.854 and so on. And the value of the second decimal place has not changed for several presses of the button. This suggests that to one decimal place, the value of the root is 1.9. But this does need to be checked. The checking process should always happen. We know that f of x is x cubed minus 2x squared plus 0.5. We're saying the root is 1.9 to one decimal place. So if we look at 1.85 and 1.95, the range within which numbers round to 1.9, then we should see that the root is in this interval. So we need to evaluate f of 1.85 and f of 1.95 and see if there is a change of sign. If we do these evaluations, we find that f of 1.85 is minus 0.013 and so on, and f of 1.95 is 0.309. Therefore there is a change of sign, and the root must be in this interval. If the root is in this interval, then the answer is 1.9 to 1 decimal place.